Let's determine the exact value of cos theta given that sin theta equals negative root 5 over 10 and cos theta is greater than 0. So basically cos theta is positive and sin theta is negative. So first we have to identify in which quadrant sin theta is negative and cos theta is positive. So for this, I'm going to utilize this cast diagram, which says that A represents all trigonometric ratio. That is, first quadrant, all trigonometric ratio are positive, and in second quadrant, sine and its reciprocal are positive. Other ratios are negative. And in third quadrant, tangent trigonometric ratio is positive and its cotangent. Every other trigonometric ratio is negative. And finally, in the fourth quadrant, the cosine and the secant are positive. Every other trigonometric ratio are negative. So we know that sine theta is negative in third quadrant as well as in fourth quadrant. And so we are looking for sine theta should be negative as plus cos theta is positive. So only in fourth quadrant sine theta is negative as plus cos theta is positive. So basically we are looking for the fourth quadrant. The angle theta lies in the fourth quadrant. So now I'm going to construct the fourth quadrant. That is we have to construct a right triangle. Let's say this is the fourth quadrant and I construct a right triangle so that we can determine the values of theta. So let's say this is the origin O and this point is A, this is B, and this is a right angle. And we know that sine theta, this angle is theta. Sine theta is negative root 5 over 10. So sine theta is opposite side over hypotenuse. The So therefore we write sine theta equals negative root 5. This is given as negative root 5 over 10, and this according to Sokotowa it is opposite side, which is AB over hypotenuse, which is OB. So this means AB equal negative 5. So I mark negative 5 over here, and OB is 10. So that is the hypotenuse is 10. Now we have to determine the measurement, that is the length OA, so that we can find cos theta from this right triangle. So let's apply the Pythagorean identity. That is in the right triangle we will have OA squared plus OB squared, that is the sum of the squares of the sides equals the square of the hypotenuse. That is in fact this is not OB, this is AB square, this is the other side, and basically OB is the hypotenuse, so this becomes OA squared plus AB squared equals OB squared. Now we can replace AB and OB into this equation so that we can determine OA. So this becomes OA squared plus AB is negative root 5. So I write down this as negative root 5 quantity squared equals OB is 10. So this becomes 10 squared. Now you can solve for OA from this equation. So I write OA squared plus negative root 5 quantity square is just root 5. I'm sorry, it is 5. So this becomes 10 square is 100. Now we subtract 5 from both sides. So we get OA quantity square equals 100 minus 5 is 95. We then take the square root on both sides so that we determined OA. So we do the square root. So this implies OA equals the square root of 95. And so we can mark this OA into our right triangle. So I'm going to get back to the right triangle and replace this OA by square root of 95. So this equals the square root of 95. Now we can determine cos theta from this equation. So cos theta, let me write here, cos theta equals adjacent side, that is OA is the adjacent side over hypotenuse, which is OB. Now we'll substitute OA, which is the square root of 95. So this becomes the square root of 95 over OB is 10. So therefore this is the value of cos theta.